we're going into chapter 6, which is about deadlocks. So today we'll have an introduction to resources, what resources are, or why do we need them, and some potential issues that can occur with the allocation of resources to multiple processes that need them. So deadlocks and resources. Introduction. So certain resources can only be used by one process at a time. Can you think of any examples what kind of resources that are? By resources, we mean CPU, memory, printers, external devices, mice, keyboards, hard drives, tape drives, USB drives, memory, tables in memory. These are all examples of resources that processes need to acquire. So can you think of any of these that can only be used by one process at a time? We mentioned that before. We gave an example with a printer. Remember that? We said if two processes are trying to use the printer at the same time, and they actually do, and we actually allow that, then the printer will start printing one line from the one program, and one line from the next program, and the third line from the third program. And when you see the print output, it'll be a total mess. It'll make no sense at all. So the printer is one example. We give it to one process at a time. When the first process is finished printing, then we give the printer to the next process. So if two processes simultaneously write to the printer, we would have interleaved lines. Can you think of any other examples? How about a CD recorder? What if we're recording information on a CD? Can we have two programs, processes at the same time record stuff on the CD? Or do we only give it to one of them at a time? So we only give it to one of them, CD recorder. How about scanner? Can we have two programs scanning at the same time from the same scanner? Probably not. Other examples are including slots in the operating system internal tables. For example, system. If two processes use the same file system table slot, that will lead to corrupt files. So there are a lot of resources that we need to be careful assigning to the processes that request them. So we need to manage these resources in a way that only one process has them at a time. In addition, the situation is even more complex when one process needs multiple resources to run. Then we really need to be careful, because what can happen is that the one process, let's say the one process needs 2 resources and it has acquired one of them, so it's waiting. The process, remember, when the process is waiting for an I/O operation, it doesn't run, it's blocked until the I/O operation is complete. So if the process is waiting on a resource to become available, that process doesn't run. It's blocked until it acquires the resource. So let's say the process needs 2 resources. One of them it has acquired and it's waiting on the second one. And then we have another process in the same situation. It needs the same 2 resources. So it has acquired the second resource and is waiting on the first one. Then both of them are blocked, waiting. So we can end up in such situations if we're not careful managing these resources. So let's imagine a fourth scenario. We have process A requests the scanner. And it is granted. We have process B requests CD recorder. And it's granted. And now process A asks for the CD. For the CD recorder. Can we give the CD recorder to process A? No, because B has it right now. We have to wait until B is finished, and then we'll give it to A. So this is denied. Denied until B finishes. And now process B asks for the scanner. Can we give the scanner to process B? We cannot, because A has the scanner. right? So B has to wait until A is finished with the scanner. So that request is denied until A is finished. Are any of these processes running right now? Are they runnable? Are they in a ready state? Or are they in a blocked state? Both of them are first, even before this happened, both of them were blocked because they need to require a resource in order to continue running. So A asked for CD recorders denied until B is finished. B asked for scanners denied until A is finished. Are they any of them ever going to run again? What do you think? Both of them are blocked waiting forever. So this situation is called a deadlock. So this is what happens oftentimes when a process is hanging. So we're running some application and it runs and it does some work and then it starts hanging. It's not crashing, it's still running, but it's not doing anything, it's frozen. Have you seen that before? It's not like it got some error and it crashed and the operating system killed it. No, it's the process is in memory, but it's not doing anything. You know, we click on it, we try to do something, it's frozen. That's the way it acts when it's deadlocked. So that can happen with threads as well. Let's say we have a process with multiple threads that run inside the process. It can happen that one thread requested needs two resources and got one of them, and the second thread the same thing. It needs the two same resources and it got the second one, and both of them are waiting on each other. So in that situation, we can have parts of the process hanging, or even the whole process hanging, because the threads inside of it are deadlocked. The same can happen over networked machines. So it can happen with threads. First of all, it can happen with processes. Threads. And networked machines which request shared drives, printers, and other devices that are shared over the network. The same situation can occur with devices in certain applications. For example, database applications. So remember we said here, one resource is slots in the operating system internal tables. So think about a database application which has records. And these records need to be updated, modified, deleted, created, and so on. If we have two users, we talked about this example before. If we have two customers of an airline and are trying to reserve a seat on a flight, and so the application which makes the seat reservations, it has pretty much one slot in a table for each seat. So the situation is similar to slots in internal tables. And can we have two customers, in this case it's not two processes, but two customers trying to reserve the same seat at the same time? If we allow two customers to reserve the same seat at the same time, then what? When they get on the flight, who is gonna sit first? So we cannot allow that. So in database, this situation can occur without I/O devices. For example, in a database system. So when we are reserving the seats, what we're going to do is the first customer that comes and tries to reserve the seat, we will lock that seat. We will lock that slot in the table until the first customer or process or thread is finished with that. If it's going to reserve it or not, if it's some information in the database that needs to be modified, updated, whatever it's doing until it's finished, that slot or seat is locked. And when it's completed, we can allow other customers or processes or threads to access this seat. So the process, so if the process A blocks a one record, and then but it also needs a second record. So process A needs record 1 and 2. And then process B is locked to the second record. But it also needs the first one. So again, both of them are waiting on each other. So this kind of situation can occur with database systems and other applications. So these kind of deadlocks can occur when processes have been granted exclusive access to a resource. Whether the resource is deadlocks can occur when processes have been granted exclusive access to devices such as the printers and the scanners. Data records, such as the seat in the airline reservation application, or records in a database system, files, and other objects. We refer to these objects granted as resources. We have two types of resources. One of them can be taken away from the process without interrupting or without affecting the process functionality. So they can be taken away with no ill effect. And then we have, why would we want to take them away from the process? Why do you want to take the resource away once the process has it? Let's think about this situation one more time. The process A needs two resources, scanner and CD recorder. It requested the scanner and it got it. The process B needs two resources, the same ones, the scanner and CD recorder. It requested the CD recorder and got it. Now process A cannot get the CD recorder, it's waiting on B. And process B cannot get the scanner because it's waiting on A. So do we want to take one of them away from the one process so that the other one can run? Or are we going to leave them deadlocked forever? So that's the reason we want to take one of them away. So if we take away the CD recorder from process B, then A will ask for it, it will get it, it will have both of them, and it will run, it will finish running. And later on, B can get both of them and also finish running. Some resources are okay to do that. There is no ill effect. But there are other sources that we can't do this so easily. Because if we do that, we would cause the computation to fail for that process. These are non-preemptible. So if we take them away, computation will fail. Most of the deadlocks would involve this kind of non-preemptible resources, because if they're preemptible, we can easily resolve the deadlock. But if they're not, then we have a real deadlock. So, in in order to use a resource, there are three things, three events that are required.